How's it going, everybody? This is Luis back with another video on the channel. This is going to be the course of Haxe programming language, which is open source, high-level, strictly typed programming language with the fast optimizing cross-compiler. This word cross-compiler is very interesting. It means that if you write Haxe code, you can compile that code into various other programming languages such as Python, PHP, C# or C++. You can even compile down to JavaScript, which is very, very interesting. Haxe has a lot of use cases. We will talk about use cases when we talk about the ecosystem of Haxe programming language or Haxe overall. Now, this is being used in games mostly, but you can actually build websites, mobile application, command line application, desktop applications with Haxe. Basically, you write Haxe code and you can compile that code into various other technologies. Here's the compiler targets available to you. So you got JavaScript, eval, JVM, PHP 7, C++, and so on. So yeah, we will start by setting up Haxe locally on Mac, and I'll show you how you can set it up on Windows and Linux as well. So this course is targeted towards people who already know programming and they want to get up and running with Haxe as soon as possible. So let's get started with Haxe by setting it up locally. You can download Haxe by clicking on here, click on that, and then here are the installer for Windows, Mac, and Linux. You can also download the source code because it's open source. So for Windows, you most likely going to use this Windows 64, and you can also download binaries or installers. So I recommend you go with installer, easier to set up on Windows. On macOS, it's fairly simple. All you gotta do is just click on OS X installer, and you will see that your Haxe 4.2.4 will start downloading. And you can double click on it and follow the installer. I'll go back, and you can also use this Linux. And here's a guide to install Haxe on Ubuntu, Debian, Fedora, CentOS, open source. So this guide is pretty good. You can just get up and running by following this guide. Now, how I'm going to set up Haxe, I'm going to actually use a Docker image to run Haxe. This way, I can keep my Mac clean because I might not need Haxe specific version. So I will set up the Docker image and then install Haxe there, and then we'll use VS Code to remote into it and then start coding from there. I'm going to go to Terminal. And here I've got this AW2 tar file. This is an image for Docker. So I'm just going to say docker load-i, and I'm going to just load this AW tar. This is going to take a bit of time. Once this is done, what we're going to do is we're going to SSH into this image, set up Haxe in that. This image is using Debian as base operating system. So we have this image loaded. I'm going to go to Docker desktop. Here's the image. So I'm going to click here and let's just name it Haxe for this container, run. And as you can see, our container is running now. I'm going to click here and that's going to open this into this terminal. Type bash. Now we're going to go to Chrome. I'm going to just put the terminal on the side and then put the window there. Now here's how you can install Haxe. I'm going to just copy this, paste that, and we don't really need to use sudo because it's a container. So let's see what happens. Now it's installing something. Then we're gonna just use this command, copy this, paste that there. So it says Haxe lib repository is now at this root Haxe lib. So that's good. So now we should be able to use Haxe. I'm going to just close this and we go to Docker desktop. I'm going to click here again and type bash here. If I say Haxe version, you will see that we have this Haxe compiler basically working. So it's time for us to open up VS Code into this container. Here's the container running. I'm going to say attach VS Code. The extension tab, you want to type Haxe. Install extension pack basically in that container. So that's going to install pretty much all of the Haxe extensions that are required to be productive with Haxe. In the container, I'm going to create a new Haxe tutorial folder and navigate to that quickly. We're going to set up a new project in this folder, and I'm going to target the compiler as JavaScript. So I'll use the terminal. I'll just make the command let's say project/source. So it says, cannot create that. That's fine. I'm going to create a new directory called bin. And within these two directories, first of all, let's go into project and let's create another directory called source. All right. And then I'm going to create another directory into the bin called JS. Let's create a new file. We are going to call this build.hxml. And this file is going to have all the compiler configuration. For JS, we are going to just paste this. So it says lib is hx node.js, and then it's going to copy from source, and you're going to use this main.hx file as the main file. So that's what we're going to create now. So let's create a new file, main.hx. And that should go inside the source folder. We're going to specify a class main, and we're going to use this static function. There's a typo here. We needed another S to make this a class. I'm going to use haxe command, and we are going to use this configuration file to compile this class into JS. I'll use build.xml file. I press enter, and now it says library Haxe Language is not installed. So we're going to have to install this. So we can use this haxe lib install hx node.js command. This is going to make sure it will install the compiler. Let's go take a look at build.hxml file. So here we got a few arguments. So we got the first one is lib, which is telling which library to use to compile this main file into JavaScript file. And here we're specifying it's going to compile this main.hx file into this bin/main.js file. We also have this flag, which basically is going to make your compiler run faster. So analyze, optimize. And then you got this project, which is basically telling the compiler where the source file is. Now I'm going to go to terminal. Let's make it a little bit bigger. I'm going to just use haxe build.xml file. Enter, and you will notice we have a new file called main.js. I'm going to open this file, and as you can see, here is our compiled version of our main.hx file into JavaScript. This code is quite long, and it might be scary to you because that main.hx file was just a small file. All it did is just use this system println hello world. Now, if we run this main.js file using terminal, so to say node, and the file is in bin main.js, enter, and you will see it's got this hello world output, which means it is doing what it's supposed to do. But all that code is really scary, right? We don't really need to go into what it's doing. It's basically we're using this system. That's why it's got all the dependency from Node.js. Now I'm going to go to main.hx file. I'm going to change this line to just trace. All right. Let's see here. Let's save the file, and I'm going to go and recompile this project. And if you look at JS file now, it's now a lot simpler. So all it's doing is just creating a global module. It's creating this function, and then it's just using this console.log, and it is logging hello world. Let's try compiling this code into Python as well. So here's on the top, we're using the library, and then I just remove that. And I'm going to use this --each tag, and then use this Python, and that would be just main.py file. So to explain this, it's going to take this configuration for each task. So the first task is to compile main.hx file into this main.py, and then the second one would be bin/main.js. Save the file, and let's run this haxe build.xml, hxml, and now you'll see we have two files. We got JS file, which is doing the same thing. Then we can also see main.py file. It's a Python file. Now I have a Python installed, so I'll just use this Python dash version to check the version of Python. So version of Python is 3.9.5. I'm gonna type python bin slash main.py file, enter, and you can see it is printing out hello world, which is cool. So you wrote one file, which is the Haxe code. Now you can do the same thing in Python and in JavaScript. How cool is that? That you can write Haxe code and you compile that to in two different languages which do the same thing. So JavaScript can do a console log, Python can print out things onto the console. So Haxe is great. It has a standard library which you can use to write code, which will do an API call, for example. So next step is to look at Haxe features, like what are the classes, functions, defining variables, basically learning the syntax of Haxe in maybe in 15-20 minutes. All right, so let's get going with that. Then I'll show you some ecosystem, like what are the packages available. Then you can start writing some code, which will actually build something like web application or mobile application, stuff like that. So let's go and learn Haxe first. Take a look at language features. So I'm going to take you to documentation, and here's a guide for that. So learn Haxe. Click on manual. Find all the language related documentation for Haxe. And I'm going to mention that the documentation of Haxe is not a great thing in the world. If you go to TypeScript or any of the JavaScript framework, like modern frameworks like React or Angular, their documentation is pretty good. Haxe, it's open source. The documentation is not great or in details, but again, this course will not target towards beginners because Haxe shouldn't be your first programming language to learn. So this is for people who already understand the programming languages. So first of all, let's go types. The types available in Haxe, like class instance, enum instance, structure, function, dynamics, abstract, and monolithic. Coming from Java or TypeScript, you will learn these things in very, very less time. So first of all, let's take a look at how do we create a variable. To create a variable in Haxe is pretty simple. All you gotta do is just use a var keyword and then use the name of the variable. Let's just say my variable equal to, and now you can specify data type like string, or you can specify a number, or you can specify boolean, or you can also specify some data structures like objects in JavaScript, but we'll get to that. So here's the information how you create a variable. I'm going to go click on basic types. So basic types that we've already seen is here. These are the basic types like bool, float, and int. We go to numeric types. So here we got float and define int. Now every int can also be used where float is expected. Take a look at this 3 lines, read about it. We got overflow. And here, if you're coming from a background, we understand overflow. So it's basically telling us that the Haxe compiler does not enforce the overflow behavior. The burden of checking for overflow falls to the target platform. So if you compile the code to C++, Java, or C#, they will be responsible for checking this. Boolean, very simple. You just gotta specify true or false. White is used when you want to specify that the function does not return anything. While we're talking about this, we're going to go and create a function. The syntax for specifying types is fairly simple. You just got to use this colon and then specify the type. So in this case, we are specifying boolean, so I'll type bool. Okay, save the file and you see no errors. But if I change this bool to, let's say, string, no, doesn't work because bool should be string. So here it's saying if you're specifying a string data type for this my variable, but you're specifying the value is boolean. So if I change this to, let's say, string true, error will go away. So that's string. And if I change this to int, which is an int data type, now the message would say string should be int. So if I change this to, let's say, understand how we specify the type. Use the colon and then specify the type for your data. Let's go to documentation. Here's a void, which denotes the absence of a type. Okay. And it is used express that something, usually a function, has no return value. So if I go and change this to x void, the argument and variables of types are void and not allowed. So I don't know why you're gonna do that, but let's say if you did void, now this is basically just a standard void type. Now it has to be null. So if you go and add a value and then make a space, and the arrow should say string should be white. White means null. So if I change this to, let's say, null, and you'll see null is not a value. Okay, let's just do small n, and now you see there's no error. So white basically means that there is no value for x. Similarly, when you're creating a function in Haxe, the way you create a function is by using, let me go to function documentation. And the way we create a function is by using this function keyword and then the name of the function and then the return type. So here you see it's specifying the type is bool and it's returning true, which is a bool. So let's go to our code. I'm going to specify a function and let's say new function. Okay. And this should return something true. All right. Now here we can specify the return type. So in this case, it's bool. Once it's bool, this is going to be okay because it is returning true. But if I change this true to, let's say, 50, there will be an error. It says int should be bool. So it's saying, hey, you are expecting a boolean value out of this function, but it is returning 50. You see the errors that we are basically seeing on the compile time. So let's go back to function documentation. So here's a function type. The function type along with a monomorph is a type which is usually well hidden from Haxe users. So here's the thing, okay? Now functions, as you know, in many other languages can take parameters. So let's say x, and then you can specify its type. Let's say I'm expecting x to be int and then y to be string, okay? Now if I go and trace x and then trace y, right? So here is saying missing return bool. Well, that's fine. We're just going to do something white. So let's change this to white, which means it's not going to return anything. Now, if I try to access this function in this main function, because this is going to run when the class gets executed. So if I say new function and then just say 50, comma, let's say hello world. All right, add a semicolon. Now here it says it cannot access new function in static function. So what's the problem here? Well, this function can only be used if you add this static keyword, and now you can see you can access it. Looking at the documentation here, I want you to read this passage and you will understand why you need this static. So here we have an old function donation as well, but don't worry if you're using Haxe version 4. Okay, so now let's go to our code and then try to compile it. So I'm going to use this Haxe build.xml, and are you ready? Enter, and you can see that cannot use white as a value. So here we got the problem. It's basically not required at all. So we'll just get rid of this and run it. And if we take a look at the bin, we got two files, main.js. Okay, that's the main.js. And we got the py file as well. I'm going to try running, first of all, main.js. Also, I'm going to move this to the right. It will be easier to read the code, or actually look at the output. So we can make the size a little bit bigger. Okay, that's good. So now I'm going to do node bin /main.js. Enter. And you can see it is printing out hello world 50 and then hello world as well. If we run python bin main.py, enter, and you can see Python is doing the same thing. And if you look at the code, it's pretty nice. You can also take this class file and basically start working directly here if you want to. So Haxe is great if the language dies. Let's say you wrote everything in Haxe and then JavaScript gets compiled and then you use JavaScript in a web page, and in about 2 years JavaScript is dead. Then what you can do is you can just use the Haxe code, compile down to Python, and use Python instead of JavaScript. So it's great. Now we were able to run our code from Haxe. Now, next thing we're going to take a look at in documentation is go back to basic types. And here we have this optional arguments and nullability. So here it says optional arguments must be accounted for when considering nullability. So let's say if we don't want to specify string, okay? What you need to do is you want to just do a question mark. Let me just give you another example. So let's say if I get rid of hello world, okay, this is going to throw an error. It's saying that not enough arguments, expected y string, right? Now this should be like optional, right? If you don't want to specify a value for this. So what I can do is just do question mark, save, and now this has become an optional parameter or argument. So here you see it's saying in the documentations is question mark, and that's what makes it optional. Very, very simple. Now, if I call this function twice, let's say 3 times, the second time I'll type second call, and I can say third call. Okay, now if I go ahead and then compile the code, okay, let's run the Python, and you can see it's saying second call, third call, but here it says none. None means that you did not specify the value for y in the first function call. So far, we've been using this Python and JavaScript file to run the code. But how about running Haxe directly? You don't want to compile the code and then use Node to run the JavaScript or Python to run this main.py file. And Haxe Simpower can basically execute this code. So if I go ahead and then type haxe build.hxml, and you'll see it will just compile it. But if we go to the build.hxml file, we're going to add a flag here. So I'm going to use this. Let's see. -- interrupt. Okay. And we don't want to compile the code for now. Let's just comment this out. Now, if I run this, you will see the results. So hello world, 50 null, 50 second goal, and third goal. So now we don't need to really compile the code to be able to see the results, if it's working or not. So now we can just execute the Haxe code directly. And this is helpful because we want to learn Haxe as soon as possible. Let's continue our journey with Haxe. So we got these classes. Classes are really part of object-oriented programming, and they're available in pretty much every programming language, which can call itself object-oriented programming language. Even JavaScript has classes now. So the way we can create a class is by using class keyword, very self-explanatory, and then you choose the name of the class, and then this can have properties or functions. Let's create a new class in the code. I'm going to paste that class instead of just typing it out. So here you can see we specified a class name followed by the class. Let me use this arrow, followed by the class keyword. Then we have 2 properties, x and y, and we specify their types as well. So we use the var keyword to create a variable there. It has 1 function as well. So we use this public function and named it as increment x. Return type is y, which means it's not going to return anything. And we're accessing this x variable, which is this one, and we are incrementing it by 1. I'll show you these operators available in documentation as well. So one of the most important function that every class should have is a constructor function. okay? And that we name new. Anytime you name a function new is a keyword. It cannot be used as a common function name. So here we got two arguments for this constructor function, which means whenever we create a new instance of my class, we will have to specify X, Y is optional. All right, go back to documentation and take a look at the same thing explained here. I'm going to go to class constructor. Here say instances of class constructor are created by using the class constructor. For example, here's a new point, right? Syntax used here is a new keyword and then the class name that you're going to create a new instance of. Let's go and create a new instance of my class in our code. So here is a new instance created with a new keyword, okay? And then use the name of the class. And we passed in two values. X value would be 50, and then the hello world would go and get assigned to Y. The reason why I'm mentioning that we're already talking about this object-oriented concept is because they are usually taught at the later stage of the course. If you go to documentation, here's an inheritance example. All you gotta do is use this extend keyword, okay? And then when you use this, you gotta specify what you're extending. So that would be another class. Once you extend the class, you need to use this super keyword in the constructor function of the class that is extending the other class, and you need to pass in the required arguments. You see this super keyword in many other object-oriented programming language, but there's one catch here. In Haxe, this is not a mandatory, and also it does not have to be the first expression in the constructor, as it says here. So it can appear anywhere in the constructor code and does not have to be the first expression, and it is not mandatory for a child classes to define their own constructor as well. Next concept in Haxe is interfaces. So I'll go to interfaces. As it says, interface can be understood as a signature of a class because it describes the public field of a class, and interfaces do not provide implementation, but rather offer purely structural information. Now, if this doesn't make sense, let me explain to you. You know, what is this? This is string. It's a type. But this is provided by Haxe, and many other programming languages provide these kind of types for all the data. Now, what about creating your own custom type? For example, here in this case, this printable is a custom type that we can create by using this interface keyword. It can have properties and it can also have functions. So if you read this here, it says the syntax is similar to classes with the following exceptions. So you need to use the interface keyword instead of class keyword, and functions do not have any expressions. Every field must have an explicit type. Okay, for example, you cannot leave this string out of this function because it has to tell that what it's going to return. All right. Then the syntax for implementing the interface is just using this implement keyword. And that's about it. So I'm actually going to just copy. Let's go and write it down basically. So we go here and I'm going to create an interface in this class. So let's say interface, and I'm going to just say my class interface. Okay. And I'm going to say this is going to have X property, which type is going to be int. It's going to have Y property, the type is going to be string, but it's also going to have another property, Z, which type it's going to be bool. Okay. And we are going to also create a function for this class. So the function implementation is fairly simple. You just go to use public function and then the name of the function and what type it's going to return. So here we have one function, right? Increment X. So I'm going to use this public function and I'm going to remove this first of all, and this is going to be increment X. Okay, and the return type is going to be white, and it cannot have this expression. So add this for the values, it's gonna take nothing. All right, so now if we want to use this interface within this class or restrict that, I'm going to use this implements keyword and I'm going to say my class interface. Now, as soon as I do that, you get an error. It says missing field for my class interface. And IntelliSense in VS Code is pretty smart. So it's giving me, hey, do you want to do a quick fix? I'll click on quick fix. It says implement field for my class interface. If I click here, it will implement the value Z with the type bool. Click. And there we go. We got public var Z bool, right? And still, there is an issue. It says field Y should be public as requested by the class interface. Well, this is public, but if I mark this as private, and let's do private, save, and now the arrows no longer there. You can see that, okay? So you can see if I remove this Y from here, class will give me an error. It says missing field because here we are signing a contract for this class saying this class is going to have these properties and this function at least. Just like classes can implement interfaces and extend other classes, interfaces can extend other interfaces as well. So let's say if I say interface X, right? And I'm going to say private, X int, right? And I'm going to remove this from here. Now, instead of using X, okay, I'm going to remove X from here as well. Now, well, actually, let's do one thing. Let's remove Y because that's not being used much. So I'm going to remove Y, right? And here it's going to give me an error. That's fine. But the error is going to be there because X doesn't exist, right? But how about extending Y? So we just say Y, and I'm going to, that's actually string, so let's do string. Now I'm going to extend this interface. So use extend and say X. All right. So now if I remove Y and then Y, the class is going to have a problem because it says missing field for my class interface. How come? Because we're not missing. We got Z. Let me just move this up here. And we're not missing anything. We got X, we got Z, and we also got this increment X function. So what's happening? Well, because this interface is extending X interface, which means the Y property is going to be part of this my class interface. That means any class that implements this interface will have to have this Y property as well. So if I go ahead and then remove this, all right, now the class won't have any error because, you know, we fulfill the contract. But if the class is going to miss any value because of the interface extending any other interface, we're going to have to, you know, add those values. So now if I go ahead and then say var Y, that would be string. Okay. And yeah, now class don't have any more errors. So that's about it for interfaces. Next, take a look at abstract class. Abstract classes are very, very common in object-oriented programming languages. So the one difference about abstract class versus a class is that abstract class cannot be used as a new instance. So you cannot create a new instance of a class which is marked as abstract. And if I read here, it says, in contrast to abstract classes, a class that implements all its method, known as a concrete class, and concrete classes inheriting from abstract classes must be declared without the abstract keyword, and all abstract methods in parent class must be implemented. Very simple, but here it says abstract classes are classes with partial implementation. As such, an abstract class cannot be instantiated. And that's the main difference. If you mark your class as abstract, this must be used by a child class and must be extended. So here it says, you see that there's a car class, it's extending a vehicle class. So that's basically the difference between abstract versus, you know, the normal concrete class. So if I go ahead and then make this class as abstract, okay, Now, if I go and make a new instance of that, so let's say my class equal to new my class, and oops, what it did, my class, you see that it's not even letting me use this because the smart intelligence kicks in and it doesn't let me use that. So let's just get rid of this line above, and I'm gonna try again. Let's say my class, and here it says my class is abstract, it cannot be constructed. You see this now? That's what happens when you mark the class as constructed, but you can extend the class. Make sense? All right, so that's about it for classes. Enums are very self-explanatory. We just quickly go through that. You can create enums like that with using enum keyword and then name and then specified values. If you're coming from Java or TypeScript, very, very simple stuff. Finish off talking about some of the basic concept of hacks. They're really common in all the programming language, and that is the reason I'm just going to quickly go through those so you at least know what's available to you and where the information in documentation. But where I want to get to is to actually use cases of hacks, like how to use hacks to build a web application. That's the important part that we're going to get to. Let's quickly go to anonymous structure. Anonymous structures can be used to group data without explicitly. Look, guys, this is just a JSON or dictionary in Python, object in JavaScript, and yeah, it's really a JSON with like parsed in JSON that you can just get the value from typing dot that. So let's say let me just copy this bit here. Okay, pretty same simple stuff. Let's go to VS Code, and we're gonna go and create a new variable. Let's say in the main class. Okay, we create this now within our, I'm going to use this public. Okay, and in the main function, I'm going to say user dot, and you can see I cannot access that. So let's just say static. Now if I type user dot, and now you can see I can access this name, right? So we can do trace user dot name and trace user dot age dot, and age has no value there, so we can't really use dot. Then if we use this POS, and then I'm going to use this square brackets and type 0, and that's just like an array at a semicolon. Now let me try running this. Let's go and just get rid of this. We don't want to extend the class. And we also would like to just fold it. Let's fold that. I don't know how to do it in VS Code, but let's just run it. Okay, let's run it. And now you can see here we're printing on hello world and Nicholas, and then the value x0y0. So that's the value that's being printed, and Nicholas. Very simple, just like object in JavaScript and dictionary in Python. So as a comma separate values. And this is basically an array. If you go to JSON for structure, same thing, it's explained to you. Class notation for structured types. So this is important. If you're coming from TypeScript, so TypeScript, and if you look at advanced types, you can create types using interfaces and type alias. So here we got interfaces, but you can also use this keyword type. You see this? And pretty much that's it in this in Haxe. So type def, create a type of it, and then you can use it. So if you go to optional, it says field of the structure type can be made optional. In addition to notation, this is achieved by prefixing the field with a question mark. So you can use this question mark to make the field optional. Or you can, in the class notation, you can use this @ symbol colon optional as well. Next guide in documentation is impact on performance. Take a look at this, guys. very self-explanatory. Extensions. It's a little bit advanced topic, so I'll just skip it for now. Let's get to function types. We've already seen function, how we create functions. So there's a function keyword that can be used to create a function. We talked about return and arguments of the functions. Very self-explanatory. Now let's get to dynamic. Now in TypeScript, there is something called type any. So if I go to type any, right, it says types will also have a special type any. You can use whenever you don't want to particularly cause a value to have a type checking. Okay. Now, same thing here. While Haxe is a static type, it can essentially be disabled by using dynamic type. A dynamic value can be assigned to any, and anything can be assigned to it. There are several drawbacks. So drawbacks are like compiler can no longer type check assignments, function calls, and other constructs where specific types are expected. So sometimes you are going to use dynamics, but it's the same that if you use any in TypeScript, you basically lose the value that you're getting from TypeScript. So if you're going to use any everywhere, then why not just use JavaScript? What's the point of using TypeScript? Because any or this dynamic is not going to catch the errors on the compile time. So, well, try not to use this. Here's some more information. Dynamic with type parameters. Like you can have dynamic, but also specify the parameters for it. Have a read through this. You'll get to that because it's pretty simple, because you can have like a dynamic object, but you want the type for those values to be string. Okay. Dynamic access. Dynamic access in an abstract type for working with anonymous structures. So if you have a JavaScript object, right? So that can be used as dynamic access and pass in dynamic as a type for it. AnyType. All right, so here we have dynamic, but also we have AnyType. So it says any is a type that is compatible with other types in both directions. It serves one purpose: to hold values of any type. Explicit casting is required to use these values in order to guarantee that the code does not suddenly become dynamically typed. Okay, very self-explanatory. Try this example and you'll get to know what they are trying to do with any type. Next, in the documentation, we have this abstract section which talks about abstract type. Now, we can go and explain this in details, but I don't see there's a point because this is not targeted towards beginners. You should already understand some of the programming in object-oriented way in any other programming like Python or JavaScript or Java. So this is just a compile time feature which checks the types that you define. I'm not going to go into details about all of these abstract types, but you're more than welcome to take a look at them by following this documentation. It's fairly simple if you're coming from a strongly typed programming language. Let's go to type system. And type system is one of the most important topic in most of the programming languages which are strongly typed like TypeScript. So here we have this type system, and we have a keyword called type def. So type def is a mechanism to give a name to anonymous function or complex type. For example, we had these anonymous structure like a JavaScript objects. You can specify types for these. So let's go back to type system and go to type def. And here you'll see you can define type def and name it, and then you can specify its name. For example, here's a user, right? So it's going to be anonymous function, but you can also provide age and name as types, and then you can use this as a type for that particular anonymous object. We go to type parameters, and here it's talking about parameters for your types. Oops, let's go back. And you can use this type def with class, enums, enum constructor, function, and structures. It's fairly straightforward, guys. Take a look at this example, and you will get to know how the type parameters works in Haxe compared to TypeScript. Now let's not go all over type system because that will make this video very, very long. Few things before we wrap up all the programming basics for of Haxe. Just gonna go take you to generics. Generics are very important as well. And in TypeScript, if you refer to generics, that's basically the same thing in TypeScript as well. I'm not sure where the document where the documentation is about. Yeah, there you go. Generic object type. So here you can take a look at if you define interface and how do you define its type like this, right? This opening and closing greater than less than 0, and same thing happening here as well. So you can create a class with its type, and then you can pass it the type from outside, and you can do that by using generic. So here you got symbol at colon generic. That's how you mark it. All right, so we talked a lot about what are the features available in Haxe. Now, this video will be almost 10 hours long if I go through every single feature available in documentation and also showing you the language itself. Now, that's not the purpose for this video. So I want to get to how you can use this into an actual application. So let's take a look at some of the ecosystem of Haxe programming language. First of all, here is the official documentation, and we've been following that. But you can also go to standard library. A standard library is where you'll find all the standard data structure or all the standard packages that are already available to you for using. For example, this math library, which will give you all the functions related to math. We go back, and you also have this system library, which gives you ability to talk to the native system as well. There's a lot of things that you can find in standard library, but not everything will be available here. So for that, you're gonna go to Haxe Lib. Haxe Lib is like a node package manager for Haxe. So we go to the official page for lib.haxe.org. And this is where you will find all the packages that are available to you. It's like a node package manager or NPN for Haxe. Here you'll find projects like in web. So you have this HHP Haxe hypertext preprocessing template system that can be used to write your HTML. You can also take a look at some of the React stuff. So React, where is it? Okay, so React Native for mobile application development. This project is pretty cool. And the good thing about every package is that if you click on that, it'll give you some information how you can use this package and start working with your end goal. Okay, so let's go to the JavaScript. And within this JavaScript, you can find a lot of packages which are like Webpack, which will help you to do the Haxe code, live reload that code while you're working on your web application. So that's pretty good as well. Now, it's up to you how you explore things, but I would highly recommend to take a look at this Haxe tip. You'll find a lot of resources here that are basically out of the box and ready for you to use. Now, that's basically it. You know how to set up a Haxe project now. You know how to compile down to JavaScript and Python. And if you want to learn more about how do you target specific language, here's target details for example, for Java. So you click on Java, and it's going to give you getting started with Haxe in Java. It's going to take you to this page where I'll show you how you can compile Haxe into Java. I think so far what we've learned, it's good enough to get you up and running with Haxe. A lot of information you'll find is in Haxe Lib, in all the different packages, and here in the documentation. I'll create a separate video where I'll show you how you can set up separate projects, like a project for React Native or project for web or project for desktop application. I'm going to be creating separate videos for those to fit that into this video. It's going to be very long, and this is just a crash course. So yeah, good luck with your Haxe journey, and stay tuned for more Haxe tutorials. See you guys in the next video. Cheers. Bye.